right, so today we're going to talk about my favorite shape, a circle. Um, Circles are different from any other shape we've talked about because they're not made up of segments. A circle is a set of all points in a plane that are equidistant from a fixed point, what we call the center. A circle is named by the point in the center. So if you look at this diagram right here, the center point is F, and so we would name this circle circle F. And there is a symbol for a circle, like how there is for a triangle. So the symbol looks like that. It's a circle with a dot in the center, and you follow it up by just the center point. So that in blue is called the way you name the circle. Circle F is how you pronounce that. A lot like how we see a triangle symbol, we know that's triangle, and then whatever the three letters are, triangle ABC is how you would name some arbitrary triangle. All right, so the radii are these segments that connect to the center point and the circumference. This is some point on the circumference. Y'all have seen these words before. The first three bold words under the diagram. So the circumference is the outer boundary of the circle, the curve. You can also use the word circumference to talk about the distance of the outer boundary. And the radius, and then the diameter. Words I'm sure y'all have seen before with their definitions listed below. Okay, so radii right here, I'm going to name them. There's three of them. There's segment FR, segment FO, and segment FG. And it doesn't matter if you put the center point as the first letter. And then the diameter is segment GR or RG. Okay. All right. So moving along, y'all have seen those words before, but what's probably new to y'all are these set of words in bold. So a chord is a segment whose endpoints are on the circle. So if you look at this diagram, the purple segment right here, this is is a chord. A diameter can also be called a chord. So all diameters are chords because diameters have two endpoints on the circumference. But more specifically, a diameter has to pass through the center point. But all diameters can be called chords, but not all chords are diameters. All right, and then a secant, the next word, is this green line. So a secant is a line that intersects the circumference at exactly two spots. So it's like a chord in the sense that it touches the circumference in two spots, but a secant is a line and not a segment. And then a tangent is a line or segment that intersects the circumference at exactly one point. So this blue line right here is what we call a tangent. And you've recognized that name tangent before with trigonometric functions. And there is a relationship between what is called a tangent on a circle and the trigonometric function, a tangent. But you don't have to worry about that until you get to pre-calculus. But yes, there is a connection to that trig function. And then point of tangency is the point where the tangent line or segment touches the circle. So just know a tangent is a very important word that will show up again in algebra and calculus. It's just a line that touches the curve at exactly one point. Okay, that's what we should know a tangent is for right now. All right, so moving along. So example 1, we want to name the following from the picture to the right. All right, so I'm going to take a moment to do that. Okay, so these are the answers to these following questions. So notice chord and diameter both have MH because this diameter MH is also a chord. So the chord is a segment where 2 points are on the circumference. And then, so if you look at the top right here, you could consider just this segment right here, segment GH, as a chord GH, if you're just talking about that specific part of that line. Or you could call that whole line a secant. And so I have that mentioned for secant GH and also chord GH. Okay, so our important theorem for this lesson is a radius is perpendicular to a tangent line or segment at the point of tangency. This is an important theorem about circles. So I'll draw this out. So if you have a circle and you have a radius and a tangent where they both meet at the same point, right here, for instance, where I'm putting right here, like I'll call this point F. So if you have a radius and a tangent and they meet at the same point, they will always be perpendicular. So they will form a right angle. I'm going to skip example 2. I'm going to save that for a later time because the algebra is complex for the time being. So on example 3, it says, what is the measure of OC? So this is given information. Line AC is tangent to circle O at point C, which is important. So if we know a line AC is tangent and we see OC is the radius, we know there is a right angle at that point of tangency based on the theorem we just looked at. So if there's a right angle here, we see there's a right triangle formed, and we can use rules that we've talked about with right triangles. The most common one being Pythagorean theorem to help us solve for segments on a right triangle. So in this case, there's r, the radius, and there's another r. And so what we can do, we can say is r squared plus 4 squared equals the whole hypotenuse squared, which is r plus 2, or 2 plus r. Okay, and we have to put this in parentheses to represent the whole hypotenuse and then square that. So this is Pythagorean theorem, and it's going to allow us to solve for r, which is going to represent the measure of OC in the end. So we're going to apply Pythagorean theorem. We're going to apply these squares. Be careful on this binomial when you square it. You can't just simply say it's r squared plus 2 squared. You have to expand out this expression to be r plus 2 times r plus 2. Okay, which is different from r squared plus 2 squared. So be very careful when you see this. This is a common algebra mistake a lot of students make. Okay, and then we have to double distribute the right side of that equation, or FOIL it, as some teachers say. So r times r is r squared. R times 2 is 2r. And then another 2r. And then 2 times 2 is 4. All right, and then the left side we still have as r squared plus 16. Okay. And then we want to combine like terms. So notice r squared is on both sides of the equation. So you can cancel them out, or just algebraically see, minus r squared will create 0 on both sides. And then we're left with 16 equals 2r plus 2r is 4r plus 4. And this is a much easier equation to work with. So minus 4, 12 equals 4r, resulting in r equaling 3. So if r equals 3, we know the measure of OC is 3. Okay, so on this last question, this last example, given the measure of OT equals 10, and measure of PT equals 8, and measure of OP equals 6, is line PT tangent to the circle at point P. So notice we aren't given any information as to is this line PT tangent, even though it looks like it. So we're going to prove if this is actually tangent to the circle using Pythagorean theorem, because if it is indeed perpendicular, if that line is tangent to the circle, there should be a right angle formed there. And so the way to prove if a right angle is formed right there is by doing Pythagorean theorem, called the converse of Pythagorean theorem. That proves if a right angle is formed with a right triangle, with a triangle. Okay, so measure of OT is 10, PT is 8, and OP is 6. So if we apply Pythagorean theorem to that triangle, and this equation is true, then we can say that is a right triangle, therefore angle P is a right angle. So if we do this math, we see 100 does equal 100. Therefore, that triangle is a right triangle. Therefore, angle P is a right angle. Thus, line PT is tangent to this circle at point P.